We are live. This is Math 75, and this is a camera that's having trouble focusing. There we go. And this is section 1.2 functions, part 2, and we are in domain and range, which means we are just mere minutes from the finish line of 1.2. And then we will be done with functions and get to move on to some other cool stuff in 1.3 and 1.6. Yay! But first, we have to talk about domain and range, which is a really important part of both graphing and of functions. So, domain. Hopefully, if we were in a classroom, I'd say, what's the domain? Everyone would yell things. It's where the king lives. It's, something you have to pay for every year so you can have a web page. It's lots of definitions. But in math, a domain is the set of inputs for a given function. And I'm doing that shorthand where I write function like f and then n. Okay, so what's the range? Like home on the range, except this is with regard to math. And given that this is the set of inputs for a given function, any guesses about what this would be? You're right. Sorry, my hand keeps flying up. I don't know, it happens that way sometimes. The set of outputs, woohoo, for a given function. Now, the domain has to do with the set of x's, and the y has to do with the set of y's. The y has to do with the range, has to do with the set of y's. And the only way that I know to remember which is which, at least back in the beginnings, was that D comes before R in the alphabet and X comes before Y in the alphabet. So that's how I match them up. The domain goes with the X's or the inputs. The range goes with the outputs or the Y's. In I comes before O in the alphabet. So it kind of all matches up. And the thing is sometimes the domain and the range are really painfully easy. And sometimes the domain and the range will make you want to hit your head against a wall. Don't do this. It's not worth it. Protect your brain. Maybe, get angry at your pillow or something soft. Okay, so find the domain and range of each of the following functions. And then there's no explanation. So let me try to walk you through a couple of ideas. So the domain, when we say find the domain, we assume that we're going to start with the set of real numbers, all the numbers that we use for finance and economics. So reals include all of the rational numbers, all the irrational numbers, but we don't include the imaginary numbers. Those are part of a bigger set called the complex set. We're not going to use that in this class. So this class is just going to start with the reals. And then what we're going to do is we're going to say, okay, but is there any reason to be cautious? So in other words, if I look at y equals 3x minus 2, is there any reason to believe that there are any x values that can't be plugged in? And I would claim the answer is no. Any given x value, it may be very large or very small, but you can multiply by 3 and then subtract 2. So the domain for this one is the set of all reals. So you can either write all reals, or you can just write this symbol for R, which is a capital letter R with an extra line in it. Okay, so what's the range? This one's a lot harder. Now, if I were to tell you that the graph of this, which you guys know how to graph, this is a line, you should be able to graph it, y equals 3x minus 2. So it is a graph that looks like this. It's a little steeper than this, but it's about this. Let's take a look. This, and let me put blue over it. There we go, so it's easier to parse in the video. Notice how the arrow keeps going up and this end of the arrow keeps going down. Is there anything that I've jumped over or skipped? No, it looks to me like this goes all the way and this goes all the way down. This would be the set of reals or all reals. Now, there is a terrible thing that WebAssign does, and I don't know why they do this other than they are truly sadists, and that could be true. And that is that sometimes I would want to say the set of all real numbers, but they would say no. They would say this would be the set from negative infinity to positive infinity. So that is set notation. It means start at negative infinity, which is a concept. It means start all the way at the negative numbers, come all the way through to all the positive numbers and as big as it wants to get. We use parentheses on each end because these are not numbers. These are concepts. So you can't actually have negative infinity. It's not a number. It's just an idea. Smallest number you can think of, largest number you can think of. There you go. So unfortunately, WebAssign might occasionally ask you to do that. But it is so inelegant. This is so much prettier, but just FYI. Okay, next up, we're dealing with a radical or a square root. Y equals radical x. So in other words, we got to be able to put x into a square root. And so you got to know something about square roots to know what values of x I can put in. I'm going to give you a chance to think. Can you take a square root of 0? And the answer is yes. In fact, there's only one square root of 0. Square root of 0 is 0. Can you take a square root of a positive number? Absolutely. Can you take a square root of a negative number? No. So what we know for sure is x has to be bigger than or equal to 0, or in interval notation, we've got from 0 with brackets because it's equal to all the way to infinity. Okay, tell me about the range. See, the range is usually harder in my mind because it's not the part we usually think of. We usually think of what goes in, not what what comes out. So for the range, I want you to imagine what numbers can come out. Could 0 come out? Yes, you could take what is radical 0 or the principal square root of 0 or square root of 0 and you get 0. So 0 could be an answer. You can get a lot of other answers, but I will give you a hint here in front. There's no sign listed, so it's always going to be positive or 0. You can't get a negative number to come out. So interesting enough, the answer is the same. Domain and range both have the same interval from 0 to infinity. And if I were to show you the graph, the graph of radical x looks like this. And you can see that x starts at 0 and goes all the way to the right, but it does not go to the left. And you can also see that y starts at 0 and goes up. It kind of heads up slowly. It never goes down to the negative side. So you can kind of see what the domain and range are just from the graph. What about this one? Now, in my mind, let me write a bigger version so you guys can see it more easily. In my mind, this is the easiest one. Basically, the domain says, don't you dare let x equal 4. Because why? Well, what happens when x is 4? Then it's 4 minus 4 in the denominator, and that's 0, and that's undefined. So with a rational function or a fraction, you have to worry about the denominator. Don't let x equal 4. Okay, but what about the range? This one's going to be very hard to convince you of. But I'm going to just tell you the answer, and then let me see if I can explain it. I claim y can't be 0. And you're all looking at me going, what? And I'm going to say, I know. There's nothing about, if you've never done this analysis before, you're looking at it going, what is even happening here? And so let's look at the function. How could we make it equal to 0? How would that even be possible? What could we do here? So if something is going to equal 0, can we put 0 in the denominator? No, because that's not 0, that's undefined. So how do we make a 0? Well, 0 is equal to 0 over 1. To get a 0, you have to have 0 on top. But this one has 2 on top. It doesn't have 0. There's no way. Now, you can put 0 on top of anything and you'll get a 0. It doesn't matter what 0 is on top of. All these are true. 0 on top of 1, 0 on top of 5. It does not matter what you put in the denominator. If it's 0 on top, you get a 0. But that's the one thing that we can't get because the numerator is 2. So this is not possible. Y is not equal to 0. This one is one of the hardest things. So, be kind to yourself, be generous with yourself, be forgiving, don't bash your head against any walls. If you get stuck on the homework, keep asking questions, ask tutors. Tutors are the great thing about tutors is that they say it in a different way than I say it. So I'm going to tell you stuff, and if you come to my office hours, I'm going to say it kind of the same way because I'm the same person. But tutors are completely different people, believe it or not. They're not me, they're someone else. And they have their own ways of thinking about it. So if you talk to them, it could be that one of them says something so brilliant, you're like, oh my gosh, so much easier. So talk to tutors, talk to friends, hey, maybe this is a great thing to talk about if you're at a party and the party's gotten a little bit slow. Be like, hey, everybody, you want to look at domain and range of some functions? And everyone's like, yeah, yay. And then you'll be like the hero of the party. I believe this in my heart. Now, the bad news, if this weren't already enough bad news, x is not equal to 4 is not what WebAssign wants. What they want is this monstrosity. Don't even get me started. If I think too hard about this, I will start screaming. And they don't want y is not equal to 0. They do. They want this. And again, I feel like Hannibal Lecter is asking me, can I still hear the screaming of the interval notation? And the answer is yes, I can. I can in my dreams. Oh. So what the heck is going on here? Well, this is the ugliest way to write don't let x be 4. So instead of just saying don't let x be 4, they say let x be everything up till 4. Carefully step over 4 and then keep going. Same thing here. Let y be everything up to 0, step over 0, and then keep going. The u in the middle means union. And this is hideous. And I regret even showing it to you. I feel like I've done you a great disservice in your life. Okay. So shall we turn the page? I don't think I can turn the page fast enough. Okay, shall we do one more problem? One more problem. One more problem. One more problem. It's got multiple parts and it's a word problem. Oh, you tricked us. Yeah, I totally tricked you. But it's not as hard as it looks. It looks very fancy, but you can send, write home, if your family lives somewhere else, be like, yeah, this is totally what we do in math. And then they'll be like, ooh, you must be so brilliant. And then you'll say, yes, I am so brilliant. Look at me doing word problems, hard word problems. And don't tell them that it's actually not going to take that long. So this is a really weird problem, but I picked it out because I think it's got some interesting points to talk about, even though it's really weird. It's all about mortgage payments. This is from the book. I did not write this. This table right here shows the approximate number of years it will take a couple to pay off, and I know you're all going to laugh, a $100,000 mortgage. A mortgage is when you buy a house or a condominium, you buy a piece of land usually, and you pay it off, monthly, usually over 15 or 30 years. And I know there's nothing in the Bay Area that'll cost $100,000. It's impossible. So, I think you could get a box, not on Market Street, but maybe south of Market. You could get a box for 100,000. I don't know. So we're going to pay off a $100,000 mortgage at several different interest rates. Now, so this is where it gets weird. here are the interest rates. And so basically, there's no way that any one person could face all of these interest rates. When I am recording this right now, interest rates are a lot closer to 2.6. They're around the 3%, 3 to 4% right now. Some people, some special deals can get down into the twos, I think. But 9% hasn't been seen in a very long time. I want to say 20 years. We haven't seen interest rates this high. So there's no time in history when you'd face all of these interest rates. I think the problem is it's focused on the idea that if you pick a person in history and they bought a $100,000 mortgage, how do the different interest rates affect how long it takes you to pay them off? I think that's the problem. So they're determined they're going to pay $800 per month regardless. And if they do this, then for example, if interest rates are 2.6%, then it will take them 12 years to pay off their debt. And if interest rates are at 9%, it will take them 30 years to pay off their debt, paying the same amount per month. So this is a different way of looking at interest rates. We will in chapter 6 look into this much more closely. So right now, this is just kind of to whet your appetite. So first question, what is f of 6.3 and what does it mean in English? So go ahead, either pause the tape and figure it out or answer it quickly. I'm going to pretend I'm listening. You're right. Okay. F of 6.3, I got my handy dandy highlighter there. F of 6.3 equals 17. And what does it mean in English? Again, I have very, very low expectation for the actual language. I want you to get the key points. So you need to say at 6.3%, it will something like this. Take them 17 years to pay it off. Something like that. It doesn't have to be exactly that. It can be something close. The important parts being it's 6.3%, right? R is the interest rate, and F of R is the number of years. So 6.3%, 17 years. Use some words in the middle. We're good. Okay? And then next question. So A was the yellow one. So B is going to be orange. I have to wipe off the orange a little bit. It got a little smeary. B. So if f of r equals 30, what is r? Okay, so I'm going to give you guys a moment. If I keep moving the paper, it's going to be impossible to do. I realize that. So if f of r equals 30, what is r? And I'm listening, and you're right. It's this one right here. F of 9 equals 30. At 9%, it will take 30 years, so R is 9. Okay, part C is weird. Let's see, this one's too dark. C is going to be the purple one. We're looking at 2.6 here. And we're looking at 5.2, believe it or not. Okay, so what the heck is going on? Well, I'm asking, does 2 times f of 2.6 equal f of 2 times 2.6? So in other words, can I just stick the 2 on the outside? Inside. Can the 2 just slide inside? So let's look at 2 times f of 2.6. So what's f of 2.6? F of 2.6 is 12. So this is going to be 2 times 12, which is 24. Okay. Second question, what's f of 2 times 2.6? That's f of 2 times 2.6 is 5.2. F of 5.2 is 15. Are these two equal? Not equal. Does 2 times this equal this? And the answer is no. So in other words, the two cannot just slide inside. It's really different. So the interesting thing here to learn is that as we double the interest rate, we did not double the number of years. So interest rates are doing something really weird. And what I'm going to tell you is, spoilers, they are exponential. So they look like that. I don't want to draw it because it's too much of a spoiler, but it looks like that. Goes up like that. So in the beginning, it's kind of flat, and then all of a sudden, boom, it goes up like a rocket ship. Okay, so in other words, be careful. A 2 on the outside is not equal to 2 on the inside. Last one. Are you guys excited? I'm so excited. What is the domain of f of r? And I told you what it is. It's 0 to 100. Why? Now, at this point in the classroom, you'd all be yelling out at me, it's because, and so I'm going to say, yes, you're all right. And let me say it, what you've all said. Basically, at 0% interest means the loan has no interest, which means that basically you got the money for free. So in other words, somebody else bought the mortgage for you and is letting you pay them off without paying them any interest. Is it possible? Yes. Is it likely? No. No, that someone would give you a loan with 0% interest. They like you a lot. In other words, they're going to give up $100,000 right now to buy the house and let you just pay them $800 a month. Wow. Okay. And then what's the 100? Well, 100 would be 100% interest, which means that basically every year you have to pay the full value of the mortgage in interest. And that is kind of horrific, right? If you can see, if the interest rate is 9%, it would take you 30 years. So you can imagine if the interest rate were 100%, this would be really, really, really high. But basically, because R is an interest rate, because it's an interest rate, it basically sits between 0% and 100%. Having said that, do people charge more than 100%? Absolutely. Check cashing places regularly charge more than 100%. They charge really, really high interest rates. And that's why there are so many politicians who've tried to limit what they can do, because check cashing places are really mean, actually. Not a very good deal. And usually when people go there, they don't have any other options. And so the check cashing place can charge as much as they want. So it is possible to pay more than 100%. We're going to go with between 0 and 100 because it is an interest rate and percentages go from 0 to 100. Woohoo. That's it for 1.2. I'm so excited. I'm so proud of you. Godzilla is so proud of you. You made it. Yay. Next up, 1.3 and 1.6, which we will start to involve a lot more of business and economics in with the math. And then when we're done with that, we're going to go on to chapter 2. Are you excited? I am so excited. Woohoo. Math on, guys. Math on.